In this video, we're going to have a look at how to calculate the total surface area of a composite 3D shape. When you're finding the total surface area of a composite shape, there are two different methods you could use. The first one is drawing a net, which consists of the individual sides that are present within the composite shape, calculating the area of each of those shapes that make up the composite shape, and then adding all of those shapes together to find the total surface area. The second method is by using formulas that you know for total surface area of 3D shapes. First you need to do is break the composite 3D shape into smaller shapes, calculate the total surface area of each of those individual shapes. If those shapes join and some of the area of the individual shapes disappear, you need to calculate the area of the joins and then add all of the individual shapes together and subtract any joining sides. There are the two methods you can use when calculating the total surface area of a composite shape. So let's have a look at an example and see how we can apply each of these methods. So in the example, we want to calculate the total surface area of the composite 3D shape shown. So the best way to do that, considering the shapes involved, would be to break the shape into smaller components and calculate the area of each of those components, and then add them all together to find the total surface area. So we'll start off by drawing the individual components that we need to calculate, and starting at the bottom we have got a semi-sphere that needs to be calculated. So the first shape that we are going to add is a semi-sphere. So after the semi-sphere, moving up from bottom to top, we will have the top of that semi-sphere that will also have a surface. Now looking at the top of the semi-sphere, it is going to be a circle, but that whole circle is not part of the shape. Sitting on that circle is the base of the square base pyramid. So we are going to have a circle with a square cut out. So next shape we're going to draw that we need to calculate the area of is the circle with the square in the middle. And for our area calculation, we need to find the shaded area. So the circle excluding the square. So the final shapes that we need to add to our diagram of what we need to calculate to do the total surface area calculation is the square base pyramid up the top. Now the base isn't part of our 3D composite shape, so that just leaves the 4 triangles. So next we need to add 4 triangles in to calculate the area of those. So now that we have all of our individual shapes, the next step is to go through and add the measurements we need to calculate the area of each of those. So starting with the semi-sphere, we can add in the radius of 1.5 centimeters. Then moving on to the circle, that too is going to have a radius of 1.5. We also need to add in the side of the square, which is going to be 2 centimeters. And then for the triangles, each triangle has a base of 2 centimeters and a height of 3 centimeters. So now we have all of the measurements that we need to calculate the area of each of our components to calculate the total surface area. So we'll start off with calculating the area of the semi-sphere. So we're going to call that A. So the area of A, and we can use the formula for the total surface area of a sphere and divide it by 2. So it's going to be 4 pi r squared divided by 2. So substituting in my radius, so 4 times pi times 1.5 squared, and we're dividing that by 2. So using a calculator, the answer to the surface area of the semi-sphere is going to be 14.14 centimeters squared. So I can add that to my diagram up the top, 14.14. Next, we'll move on and calculate the area of the circle excluding the square. And we're going to call that area B. So to calculate the area of area B, which is the shaded part, we're going to first need to calculate the area of the circle, the total area of the circle, and then subtract the area of the square. So area of the circle is equal to pi r squared, which is equal to pi times 1.5 squared, which is equal to 7.07 centimeters squared. Now we need to find the area of the square, and that's going to be the side squared, so 2 squared, which equals to 4 centimeters squared. So to find the area of B, of the shaded part of B that we need for our calculation, it is going to be the area of the circle minus the area of the square. So that's going to equal 7.07 subtract by 4, and that is going to equal 3.07 centimeters squared. So the area of B, the shaded part that we need, is 3.07 centimeters squared. So the last individual shape that we need to calculate is the area of the triangles, and we're going to call that C. So the area of C is going to equal base times height divided by 2. So substituting in my values, that is going to be 2 times 3 divided by 2, which is equal to 3 centimeters square. So adding that up onto my diagram up the top. Now I'm ready to calculate the total surface area of the composite 3D shape. So to calculate the total surface area, I need to go through and add all of my individual shapes together. So that's going to be the area of A plus the area of B plus the area of C. Now with the triangles, I have a total of 4 triangles that I need to include. So I'm going to times the area C by 4. So substituting in my values, it is going to be 14.14 plus 3.07 plus 3, and then I'm timesing up by 4, and all of that is going to add up to 29.21 centimeters square. So the total surface area of my 3D composite shape in the example is 29.21 centimeters squared. And that is an example of how do we calculate the total surface area of a composite shape by breaking it into smaller components, finding each of those components' area, and then adding them together to come up with the total surface area.